Unit Operation Classroom. Today we are discussing polytropic exponent for isobaric ideal gas process. My name is Shekhar Bhattacharjee. Consider a closed system. So this is a closed vessel, let's say, of 1 mole of an ideal gas. So normally N is equal to 1 mole of an ideal gas undergoing a polytropic process, which is expressed by this expression PV raised to the power N is equal to constant, where P is of course pressure, V is the volume, and N is a constant. So if the process is isobaric, then what is the value of N? That is the question. So for a polytropic process, as we have seen, this is given by this particular expression here. And the value of N depends upon the type of thermodynamic process the gas is undergoing. For an isobaric process, of course, we know P is constant, pressure remains constant. So if the pressure remains constant here, therefore, if this is constant, therefore P to the power N must be equal to constant. Okay? So for V to the power N, that means whatever the value of N, value of V, even if it's changing, to remain constant, value has to be N, the value of N has to be equal to 0, because V to the power raised to the power 0 is equal to 1. So we can write P to raised to the power N is equal to PV raised to the power 0. Of course, V is equal to constant, right? So for a polytropic process, we'll try to understand about the polytropic process a little later on also. Its industry application. For an isobaric process where pressure is constant, we have to say that N is equal to 0. So that's what it says for isobaric process. The value of N is equal to 0. So this is the correct option. Let's look at the other options. For PV, so if N equal to 1, that means P raised to 1 is equal to constant. That means PV is equal to constant. So we know that is an isothermal process, because we know for an isothermal process, PV is equal to nRT. If N is equal to 1, that means 1 mole for an ideal gas. We say PV is equal to RT, where R, of course, is universal gas constant and T is the temperature. That means because for an isothermal process, temperature is constant. So this part is constant, right? So PV is equal to constant. So for when N is equal to 1, that is an isothermal process. For a constant volume process, which is called isochoric process, let's look at it. This one, PV raised to the point N is equal to C. If you take the natural log on both sides, so natural log of P plus N, natural log of V is equal to natural log of C, which is a constant, which is another constant K. So if we take the derivative on both sides, so this is the derivative of this one, this is the derivative of this one, and if we take the derivative of one, since this is constant, this is equal to 0. And we know d ln of x is equal to dx over x, right? So this is equal to dp over p plus n dv over b is equal to 0. So n is equal to negative of this one right here. And for a constant volume process, this dV is equal to 0. Therefore, n tends to infinity. So for an isochoric process, that means constant volume process, n tends to infinity. And when the ratio of specific heat at constant pressure to specific volume, when n is equal to Cp over Cv, we know that is equal to n. That's an adiabatic process. So depending upon the value of n, these are the different types of thermodynamic processes. Okay. One question, so this is kind of like a summary concept of polytropic process. That means PV raised to n is equal to constant. If n is equal to 0, that's an isobaric process, constant pressure. That means there's a maximum heat input. If n is equal to 1, that's an isothermal process. That means constant temperature allows infinite heat transfer, whether it's cooling or heating. If n is equal to gamma, that is an adiabatic process. That means no heat transfer at all. If n tends to infinity, that's of course a constant volume process. No expansion allowed, as per example for rigid tanks. So in an industry, what is the application? Normally, we know these compressors and turbines. None of them behave in an ideal way. The fluid itself, like the gas, does not behave in an ideal way. So, let's say we say PV raised to the power 1.3, you'll find that, let's say, that constant, that of course adequately describes the behavior of the fluid during the compression process or the expansion process, right? So this, I mean, the polytropic process, where the value of has a certain value, 1.3, 1.35, and 0.4, that adequately describes the actual, the real behavior of an equipment in an industrial process. So again, the correct option for isobaric process, n is equal to 0, that is the correct option.